So this video is for my Algebra 2A class. This is not going to teach you how to solve matrices. I'm going to do that when I'm back, but I want you to practice setting them up from systems. So a matrix is a mathematical format that allows us to solve systems of equations. So a matrix starts with these brackets, and then you put numbers into them in rows and columns. So you could have, a number here and a number here and a number here, and you could go on for, as far as you wanted to go on for. Okay. Numbers can repeat within a matrix because it's not so much about the numbers that are in the matrix as the system that goes in the matrix. So when you see a system that's written like something like this, this is something where we can input it into a matrix, and then I'll show you how to solve it in a matrix more quickly than you would using substitution, elimination, or graphing. So today, while I'm not in this class, I'm over at adoption, I'm going to show you how to take this and put it into a matrix, and then you have a worksheet where you're just going to input these systems into matrices. So I'm going to do a couple of examples that I just make up. Then I'm going to pull a couple of examples off of this worksheet that you're doing today that you're going to turn in at the end of the class period to the sub. All right? So a matrix is just a formalized structure, and I'll talk a lot more about it on Wednesday. But it's a formalized structure for solving systems. And the nice thing about it is we solve systems that normally have 2 unknowns, but you could have systems with 3 unknowns or 4 unknowns or 5 unknowns or even an infinite amount of unknowns. And a matrix will handle all of that, and it as they get bigger, it's an easier method to handle. Okay, so for example, I'll leave that one up, and this is to write a system in a matrix. Okay, the first step, I don't know why I put first, is to make sure it's aligned. And what I mean by that is you want the X's in a row, you want any Y's in a row. If it's got more letters, you want more letters in a row. You want the equals aligned, and then you want the plain numbers aligned. Okay, so if it's not aligned, then what you would do is you would rearrange it using addition and subtraction to get your X's and your Y's where they're supposed to be. All right, and I'm going to start with 2 system equations or 2 variable system equations, and then we'll look at a 3. But that's really what you're going to do. Now, you're going to take the coefficients and input them in order into the matrix. All right, so I'm going to draw my bracket. I'm going to look at my first equation. The coefficient for this x, well, first of all, x, y equals numbers. The coefficient for this is 2. So it's going to be the first number in the first row and column of my matrix. Now I move over and I've got a +1, right? It's an invisible 1. That coefficient is going to go next in my matrix. Now I don't put an equals into this. Sometimes people will put dotted lines, but we'll talk about that at some other point in time. I'm now going to take my last number and put it there. So all I'm literally doing is taking the numbers from the x, the y, and the plain number and putting them into the matrix. All right, this one has an invisible 1. Be careful. That negative means that this next number is also a negative, so I get a -1 in the y column, and then I get a 2 in the plain number column. And that's all I'm asking you to do today. So I'm not asking you to solve it. I'm not asking you to really have an in-depth understanding of why this works the way it does. I just want you to practice taking a system and putting it into a matrix. Okay, so I'm going to do another one. So let's see, say I've got something like that. Now, be careful. Sometimes people see this and they're like, oh, right away, I'm going to put this into a matrix. But there's a problem with it. The x and the y are in the wrong locations. Notice the y is first and the x is second. When I'm setting up a matrix, especially to solve a system like this, I always want the x, the y, If there's a Z, the Z, or if for some reason it's not in XYZ, it's in like ABC or PQR or whatever, you generally want it to always be alphabetical. So if it was ABC, you do a column for A numbers, a column for B's numbers, a column for C's numbers, and then your answers. Or, you know, if it was P, Q, R, or whatever. So what I'm going to do, I don't need to actually add or subtract. Because they're on the same side of the equal sign, I can just exchange them. Now notice the negative comes with the x. The 3y doesn't have a sign, so it's got a little invisible plus in front of it, so it's really plus 3y equals 4. And then 2x plus 3y equals 6 is already in the right order. And now what it's going to happen is I'm pretty much going to rewrite the system in the matrix without any of the variables and without the equal sign. So I get a -1 for the x, a 3 for the y, and a 4 for the answer. Then I get a 2, a 3, and a 6. And that's the system written. All right, so now you should have your worksheet. All right, let's go ahead and let's take a look at, I don't know, let's look at the problem number 2. All right, and I put these together to be generally really straightforward. There are a couple where you're missing letters, and I'll show you an example of that. Okay, so I have x minus 3y equals -12, and then I've got 2x plus y equals 11. All right, it's already in order. That's a really big matrix. It's already in order. X column, Y column, number column, and the equal signs are aligned. So I'm just going to put in my variables. The variables on this x, or the coefficient on this x is 1, not variable, sorry. The coefficient on this y is -3, and then the answer is -12. The coefficient on this x is 2, the coefficient on this y is 1, and the answer is 11. And that's all I'm looking for problem number 2. Now, if you take a look at problem number, 10, 10 has 3 variables. And sometimes I didn't put them because I can't get my system to put the little squiggly, these little braces things. I normally like to write them when I do them by hand, but on a computer system they don't generally write them, which sort of annoys me, but whatever. But I don't think it's required. But what you should notice is that as we're putting these in, there's going to stay kind of clumped together. Now, I rewrote number 10 purposefully because if you notice in number 10, the first one is x plus y plus z equals 3. The next one, though, is 13x plus 2z equals 2, and we're missing the y. So we want to remember that there's a 0y in that location. All right, so anytime you have a system, if a letter shows up, you need a number for every letter, even if the letter doesn't show in another equation. So then the third equation says -x minus 5z. We're missing the y again, so I'm going to put another 0 in. So when I write my matrix, I'm going to put 1, 1, 1, 3, right? 1 on the x, 1 on the y, 1 on the z, and then 3 is the answer. Then I'm going to have 13 for the x, 0 for the y, 2 for the z, and 2 for the answer. Then I'm going to have -1 for the x, 0 for the y, -5 for the z, and -5 for the answer. All right, so that's problem number 10. This should not take you the whole class period because you're not actually solving anything. You're just setting up the systems. When I get back on Wednesday, we're going to talk about how you can solve these systems, and I'll show you a really, really nice shortcut for it. When you finish this, I highly recommend that you work on your missing assignments. Highly, highly recommend it. So I will have left with the sub not only this worksheet, but also your lists of missing. All right? Have a very lovely day, and I will see you tomorrow.